Let's solve these derivatives using the power rule. Oftentimes, we're just going to rewrite the problem as a number times x to a power, then we can apply the rule. This first function is 3x cubed. Here we can straight apply the power rule. The power rule says we multiply by the power. 3 times 3 is 9. Subtract 1 from the power. 3 minus 1 is 2. 9x squared is the derivative. This next function is 1 over x, and that's not in the form of the power rule. We want this as a number times x to a power. So we can rewrite g using properties of exponents as x to the negative first. Now we can go ahead and use the power rule, multiply by that power, so multiply by negative 1, x, subtract 1 from the power. Negative 1 minus 1 is negative 2. Don't add 1. It's very important we always subtract 1 from a power. That's a common mistake. H is the square root of x. We want to write this as x to a power. Square root means 1/2 power. Now we can go ahead, use that power rule, multiply by the 1/2. 1/2 minus 1. 1/2 minus 1 is negative 1/2. There's the derivative. If you like, you could rewrite this using properties of fractions and exponents as 1 over 2 root x, as well as rewriting the previous one as negative 1 over x squared. Depending on the situation, you might want to rewrite the derivative as the original problem looks. For k, we have 2 over square root of x cubed. Rewrite this as a number, 2, times x to a power. Well, x cubed, the square root is 1/2 power, and since it's in the denominator, the power is negative. Just rewrite it using rules of radicals and exponents. Now we can go ahead, use the power rule, multiply by that power. 2 times negative 3/2, that's negative 3. X to the subtract 1 from the power, minus 3/2 minus 1, minus 2 over 2, that's minus 5/2. Again, if you wish, you can rewrite this using properties of exponents and radicals. This is minus 3x to the 5th square rooted in the denominator.